Welcome everybody. Today we will learn how modern browser APIs can enhance our web projects and help us to think and design features in a new way. As we will see, many of these APIs have the goal to close the feature gap with the native apps, allowing to deliver a richer experience to our users and offer functionalities that were so far precluded to web applications and available only of native apps. I will show you several demos and of course all the code behind each of the API that I will present. However, I will focus more on live examples in order to keep this talk more entertaining and dynamic. But also because I left many comments in the code, so it's very easy to follow along. Now, if looking at the picture you're wondering whether we can launch a space rocket with our browser, well, the answer is not completely yet, or at least I would not try it with Internet Explorer 11. But that said, JavaScript went to the space. This is the Dragon 2 console using Chromium, JavaScript and C++ for the touch commands. The Dragon is the first spacecraft with the touchscreens. The interface makes extensive use of web components and the custom reactive framework. Of course, we can still have, as you can see, we can still have some hardware buttons and toggle in order to do the most critical operations. However, even if with our web project we don't plan to go to the space, still we can benefit from browser APIs, and we will shortly see how. Before proceeding, just a couple of words about me. My name is Francesco Leardini, and I work as a senior consultant and Angular trainer at Trivadis. Trivadis is an IT consultancy company based in Switzerland and covering a wide set of technologies. Even though I work as a full-stack engineer, having .NET and C# as my backend side, I have a special interest about web technologies like progressive web apps, Angular, and in general, modern web. But enough about me. Without further ado, let's start our API journey now. The first API we will see is the Page Visibility API. It provides events we can listen to in order to know when the document changes visibility. When the user minimizes, for example, the page or a new browser tab is open, this API will trigger an event so that we can query the document objects in order to know precisely whether that page is hidden or is visible. We can think practical scenarios of usage of this API when we have, for example, a carousel with some rotating products that we want to present our users. And we can stop the carousel from presenting the next item if the page is minimized, for example, or not visible. Another case could be a client application constantly or regularly pulling data from the server in order to fetch fresh new records. We can stop it until the page is visible again in order to optimize the network traffic. And this is particularly important for mobile users. Let's see then now our first demo API. This, and I will at the end of the talk, I will provide you the URL for the GitHub repo. It's the API that we will use. It's made with Angular and Angular material. But all the browsers API that we will see today, they are absolutely framework agnostic. Therefore, you can use in React, Vue.js, or even vanilla JavaScript. They all work without any problem. Every section of each API that we will discover and describe is composed by a short description. Eventually, for the APIs that are still experimental, it's described if you have to use HTTPS eventually and enable in Chrome some flags in order to make it working. Then there is the core of the demo itself in the central part, and at the bottom there is a browser compatibility section. Also very important because, and you will see especially for the other more experimental APIs, it will tell you how broad and widely used and covered is this API for the different browsers. In this case, Page Visibility API is not the newest API and therefore is widely support it. For the demo, we have a video that for us is extremely important, and we want that our users won't lose even a frame of it. Therefore, when we are here, we can let it start, the user start joining it, and then let's say go for a setup. When we change visibility, our application detects that the document is not document page is not visible anymore. And here, for the sake of a demo, I made so that the title also reflects this state. So the video is on pause. When I go back again then to the previous page, the API will trigger an event that now the document is visible again, and the video will automatically play again from exactly the second we left it. Exactly as expected. So this is a simple case how we can implement this in a real case, how we can implement this API. The code behind, and this is also a very positive and nice thing, is that it's very easy to implement this API. Now, leaving aside, as I said, all the boilerplate about the Angular framework, it's very simple, the logic. We have a video element whose I get a reference through a video element template variable that I can get in the component side, and I can use at this level in the class. So that I can listen for a document visibility change event, and then when this event occurs, I can query the document object and see whether it is hidden or not, and then apply the logic I want. In this case, I stop or I pause or I play again the video according to the visibility of the document. Very simple. Here down we just change the title, but this is not really relevant. It's just for the purpose of the demo. Screen Wake Lock API is a very cool API, actually one of my favorites. To save battery, mobile devices typically go on sleep mode or idle after a specific timeout. Could be 15, 30 seconds in most of cases, or if you set it for a longer period, of course, even 1 minute. On my phone, though, is typically 15 seconds. The Screen Wake Lock API provides a way to prevent the device from dimming and locking the screen. This is very important for web applications that have to provide some content through the web app, because it allows to keep the screen locked and always active while displaying its content. Or another case is a cooking web application providing some kind of recipe or steps that the user have to follow. And this is, as you can imagine, very important if we have to use our hands, for example, for some parts of the recipe, and to keep the screen always active and not locked. Think about if you are in a situation like this, and all in a sudden the screen goes dim and idle, and you have to unlock it when your hands are in that stage. Not very nice. For this demo, I will use my phone, because of course I cannot use my desktop for that. And I will mirror it so that we can have side by side my phone here mirrored and the desktop version aside. I chose specifically for this API this recipe that is extremely long, not because the recipe is good, I never tried, but because to give a real taste or a real case of a very, very long and with multi-steps recipe that we have to follow and use our hands to bake it and to prepare it. So let's imagine we are start cooking and I leave my phone there. In the meantime, I go on explaining about the API. The API works only on secure connections, and we need user interactions in order to enable and to get a lock, a sentinel lock. We can see in the meantime that now my phone got dim. So let's imagine we have our dirty hands, and this is the case. Not very nice. But if we explicitly say to keep the user locked through this API. Now we will go on talking, and we will see that without interacting with my phone, the phone will stay active, and so we can always keep going on with the recipe. Of course, probably we have to scroll down a little bit, but we can always use the tip of our nose for that. It's much easier than having to unlock completely the phone. So, as I said, we need to get the Sentinel lock. And I also provide another checkbox, once the first one is checked, to say that we want to get the lock back if we navigate again to the page. Because when we lose the focus, or when we navigate somewhere else, we lose this wake lock Sentinel. But doing this, we can instruct and implement some custom logic that we can request it again if the user asked like that explicitly, and then automatically re-enable it. So for the user, it will be completely transparent. As you can see, the screen didn't dim. So I now interact with it, but all the time that passed so far, the screen didn't go on idle. So it's very interesting for these kind of scenarios. And as we can see in the template is very simple. We have when the checkbox changes its state, we invoke the lock enable change method. What this does, it toggle the Sentinel state, and we can, if not enabled, we can request the wake lock, otherwise we release it. To request wake lock, we invoke the request method, of course on the wake lock object, and we pass the screen parameter. This at the moment is the only value we can pass. In the past there was also a system value, but this has been removed. And then from this moment on, our screen will be locked and dim. If we move away, I can eventually, but this part is only for demo purposes, to show through this is a Sentinel active variable, to show in the UI the state of our Sentinel. So we can listen eventually to a release event in order to know whether the lock has been released when we navigate somewhere else. Or when we navigate completely away from our application, of course, we can release all the resources in the ng destroy hook. And here, for example, we release the lock as well. And this is done by invoking the release method on the lock Sentinel object that we got initially. So very simple, yet very powerful to implement this kind of functionalities. Like, for example, if we have to provide a cook application, web application. Ambient Light API is still a very experimental API, but I think is really interesting because it might make us think already to some new scenarios and new capabilities that we can use to leverage new functionalities on web applications, especially on mobile phones, or at least devices that are capable of reading the light level around the device itself. The ambient light sensor interface is a part of the sensor APIs collection and gives information about the light registered by the target device. And then we can use these within our application. Again, for this API, I will use my phone, and as you can see already in the browser compatibility session is not exactly well supported yet. It's still experimental. Plus, we need an extra flag in Chrome to be enabled in order to use it. But still, let's see how does it work. If I now, with the phone, I go close to my lamp or my window, so a source of light, we can see that the light level increases or decreases according to how far or how strong is the light. Now, if I slowly go away from it until it's the specific threshold is reached, we can see that the live level, for example, is 50, or now even dimmed, is 50. And then the whole interface will automatically switch into, let's say, dark mode. This is the feature I implemented by using the light level around the phone. There are for sure many other cool scenarios of usage of this, but I found that this could be quite interesting. So the possibility of giving our users, exactly as it was also for the Google Maps native app, so that we can switch, if we are in a gallery, for example, automatically the application switch in the night mode or in dark mode. And we can provide exactly through our web application, exactly we can offer the same functionalities. Again, it's very simple to implement this API. It's always good when we use these APIs, especially experimental one, to prove if these are supported by our browser or not, and eventually to provide a message if not, or if available some fallback, or otherwise simply silently ignore the functionality. So we can read the ambient light by creating a new instance of the ambient light sensor object. Once we have this sensor instance, we can listen on errors, of course, especially if we didn't provide the permissions for it. Then we can, if granted, we can try again to read again the ambient light, and if the user provided, so granted permission for that, we can start done reading. And then here, for example, while we start reading with the start method, we can keep on lively reading the new values and then act accordingly. In this case, after we start reading light values, I constantly react by invoking a update theme method and passing the illuminance value. This illuminance value gives us an idea of how bright or how dark is the area or room around the device. I used these values as a threshold. Of course, you can go much more specific, but broadly speaking, between 10 and 50 is a dark or not well illuminated environment. And then above this level is a normal or even a bright environment. Therefore, you can even use different values in order to provide even more specific or advanced scenarios. But for this example, it was enough to check whether it was a dark environment or not, and then simply switch to bright or dark mode accordingly. That's it. Very, very simple, and yet could be very interesting to provide some functionality that are indeed nowadays still quite innovative and new. File system access is another very interesting API because it offers a new way to manipulate files in the local file system and provide in this way a much better user experience because it offers the same functionality that is given or provided through a native app. When we wanted to save a file or apply the changes to that file, we don't have to download it and save to a specific new location every time we want to edit or edit its content. But we can apply the changes straight and directly to it. We can even implement an autosave functionality that gets automatically triggered, maybe with a timeout. This System Access API offers two methods. One is called show open file picker, and another is a show save file picker. Of course, as the name suggests, once we invoke these files, it triggers a file picker dialog to open or save a file, respectively. Once a file is opened, we get an API. Through this API, we get a file handle object that we can use to interact with the file itself, getting, for example, information about the size or the name, extension, and so on. And typically, we want to keep somewhere a reference to this file handle so that we can reuse it to save the changes that we did to the file straight to the physical file itself without having to trigger this picker dialog or file dialog again and again. Let's see now in action how does it work. This is our file system assets API demo, and it's a typical case where we have, for example, to create a text file. We don't want to save it with a file save dialog every time and overwrites the file more and more again. So let's say welcome Conf42, and then we want save as invoke. We want to save somewhere. Let's say we want to save to a new file we call conf42 txt, and we save it. We can see on the top right of the browser that a new icon appeared that grants the read permission. So, and also read and write, because we create a brand new. So this explicitly gives read and write permissions to edit the file, and we can see this reflected here. Now, if we edit this file, we can see also we have a new button, just save, edited, and I click save. These changes is already applied to the file itself, thanks to this file ender that keeps this connection open to our file. This is very cool. We didn't have to open again the file dialog for that. And to prove that, let's say we go back on the home, I go back here, so brand new page, and I open now the same file we created, so conf42 txt. When I open it, we can see that the content that the new content that we added before has been reflected as indeed it was saved correctly. And we have on the top always the information with the icon that we can edit this file. So very, very nice to give really a new set of possibilities to our applications. So looking at the code, everything starts when we save a file. Let's say we create a brand new file and we click on save. The file handle in this case has not been created. Therefore, we invoke the save as method. The save as method tries to get the handle itself, and the handle itself is given back from these respectively these methods that I mentioned before. So the show save file picker, or otherwise, if we have just to open it, is the show open file picker if we want to open a file and not save a new file. When we save it, or when we provide options for the file dialog, we can of course provide a description, which kind of accepted extension we want to allow, and so on. But the cool thing is that now, once we get back this file handle and we keep it in the context of our application, so it's up here, then let's imagine we change the content of the file and we click on save, so not save as. If we click on save the file, we can check the file handle is existing. Yes, in that case we go straight to update the content using this file handle. So create a writable, and the rest is just a normal write to file code. So the cool thing is to keep in mind is this file handle and the possibility that it opens for us. So kind of keeping an open connection to the instance of the physical file, and then allow us to push all the saves and the changes straight to the file itself. WebShare is also another cool API. It allows to share an object with a text content, a title, and a URL using the device native content sharing capabilities. let's imagine native apps like Twitter, Facebook, WhatsApp, but also email or text messaging and other native apps that allow to receive content and so share specific content through the app itself. At least one of these three properties, so title text or body text or URL, must be defined. But it's best practice to define them all anytime, because we don't know which application the user at the end will choose. If a text application like WhatsApp, for example, the title might not be that important. But if an email app is chosen instead, then the title is used automatically as an email subject. Therefore, we have always to provide and define always if possible, of course, always the three properties. Let's see now how does it look like. It's interesting to see that Chrome recently allowed also on the desktop version the possibility to use this web share API. Now, if I click on it, the desktop detects that are some applications that are capable of interact or use this API. A few months ago, or in some previous version of Chrome, this was not possible. I will, though, for the demo, use my phone because I think it's more interesting. So here there are the two cocktail or the two recipes for the cocktail that I prefer, and let's imagine I want to share it with some friend of mine. So we can provide the typical share icon to say, okay, this content is shareable through some API, some native apps. Here, for example, I have a list that are, and I can even choose more, but I have a list of applications that could accept these shared objects. I take WhatsApp, for example, and select one contact. We can already see at the bottom that there is this object that is going to be shared, and if I click on send, I can send to the target contact a title, we can see, and then a body text, and eventually at the bottom a URL. So a very easy way to share content and to provide some more engagement for our web applications. Let's see now how does it look, or how we can create it. So our share object, first of all, we can define, as we say, title, text, and URL. And there is even a second level web share that allows to share also files, for example, images. But that said, the API is extremely simple. We just have to invoke the share method over the navigator object, of course, if the share API is allowed. And this will prompt this share dialog for us, as we saw before, and then the user can pass the specific object that we can define here to the target or chosen web application, native app, sorry. Contact picker. This is also very experimental, but also discloses a wide set of potentialities for web applications, because assessing the divide contact list so far has been always precluded to web application, and it was a peculiarity of only native apps. But thanks to Contact Picker API, we can now select contacts from the device list and use them within the context of a web application. We can extract properties from the contact list, like the name, the email address, a phone number, the city address, and an icon, of course, if these are all provided. And then we can use these according to how we want within the context of our web applications. Again, since we access sensitive data, not only there are some prerequisites that have to be fulfilled, similar to other APIs, like must be a secure connection, so we have to use HTTPS, and we can use this API only after it has been triggered with or by the user, so a click or a specific user interaction. Let's see how does it look like. Of course, in this case, we can show that since it's not available on the browser, I can grayed out, or I can simply inform the user that it's for that browser is not available. It's not possible to use it. But let's look again at my phone, and in here we can share API, just checked, no, contact picker. In here it's working. So if I click on the select list, we can have a list of all our users. And then if I choose one and I selected it, I can extract this information from my contact list, and I can use within the context of the web application. Here we can see we have a first name, last name, I have an icon, eventually the full address and the country if available. Okay, of course this is a test content, so the data it's all there, but sometimes cannot be always defined, so you should plan or design your UI that might be that is not always available, all the information, so in order to avoid that the UI might break. Bad news is that the browser compatibility for this API is not exactly wide yet. It works mainly with Android browser, Opera mobile, and of course Chrome for Android. So we still have to wait a little bit in order to make it working on a wide set of browser. But still we can use it in some cases in order to provide some enhanced functionalities or scenarios to our users. Vibration API is our last API for this session, and is quite interesting because again it allows to interact with the hardware of the device. Of course, only if the target device, for example a phone or a tablet, allows to vibrate. A desktop or a laptop probably does not allow that. It gives, as we said, it gives the possibility to our web applications to interact with the vibration hardware and maybe disclose some interesting scenarios, like for example we might provide a tactile feedback when is needed. For example, if it's a web game, some explosion occur, then the device vibrate. Or if the user has some errors in a form, then we can provide some visual errors and also eventually let it vibrate. We can pass an array of values, an integer, to the vibrate method of the navigator object, and each value tells respectively for how many milliseconds the device must vibrate and how many milliseconds should pause. Therefore we can create any kind of vibration pattern using these alternate values of vibration and pause respectively. But let's see how does it work. Vibration, yeah, in here, but I will not go through because I won't spoil it. I will let it play with it once you access the repo. I make a quiz, so there are very few steps with some simple questions, and if you answer in a correct way, then it will have 3 short vibrations, your device. Of course, you have to do it most probably with a phone in order to make it working. If you provide the wrong answer, then it will be just a unique long vibration. This also could be another scenario where we can provide some more interesting or entertaining features to our quiz or web app, according to the case, of course. And as we say, that the implementation is extremely simple because we just create eventually a specific pattern, and according to how the answer was, so correct or not, we can invoke and use one or the other pattern, so wrong or correct pattern. And then the only thing we have to do is to invoke the vibrate method using the specific pattern chosen over the navigator object. This is all what we need to do. And of course, it works only if the phone or the device is having or is proposing or providing a vibration hardware for that. And this concludes our browser API collection. Here you can find the GitHub repo URL where you can find then the demo and the code itself, plus some links to social media like Twitter and the Dove.io portal, where I wrote some articles especially about progressive web apps, Angular, and some of the modern web APIs that we discussed tonight. I hope you enjoyed this session, and I could provide some new hints, especially show some APIs that maybe you were not aware of. That said, thank you very much again for your attention, and I hope you enjoyed it. Bye.